So continuing our binomial expansion with our next example. So we're going to use 3x, we're going to complete 3x minus y to the fourth power using Pascal's triangle to do that. So in Pascal's triangle, I'm going to go to row 4 and collect the coefficients. The coefficients are 1, 4, 6, 4, 1. I notice that this is a minus, so I will start with a positive, then alternate between negative, positive, negative, and for this binomial expansion, I'm going to end with a positive. Now I'm going to start with my A term and finish with my B term. So I am going to have 1 times 3x all to the highest power of 4. And technically it's times y to the 0 power, but that would just be 1. Moving on to term 2, I get 4 times my first term of 3x lowers by 1 exponent, and my y, which is my second term in my binomial, goes up 1. So it started at 0, now it's up 1. Plus 6 is my next coefficient. I'll take my first term and lower its exponent, multiplied by the second term, and I'll raise it, the exponent, minus the coefficient of 4 times my first term, lowering the exponent, raising the second term's exponent to 3. And I'll finish with 1 times 3x. Well, that would be to the 0 power, so I could actually exclude that because it would just be 1, and it'll finish with y to the fourth power. So I'm going to check my terms. I have 1, 2, 3, 4, 5 terms. So I have 4 plus 1, or 5 terms. And my degree should always be 4. So I have 4, I have 3 plus 1 is 4, 2 plus 2 is 4, 1 plus 3 is 4, and I end with 4. So now I'm just going to go ahead and simplify the math. So I need to take 3x to the fourth power, so I will complete 3 to the fourth power, which is 81, and I will distribute that fourth power to the x. I will need to complete 3 to the third power, which is 27, times 4 is 108. I'm going to distribute that third degree to the x, and my y will be to the first degree. Plus, I'll take 3 squared is 9, plus 6 is 54, x squared, y squared. I'll have 3 to the first is 3, minus 4 is 12x, y to the third. And I will finish with 1y to the fourth power, so I'll just understand that that is 1 before that y. Let me clean this up to make this just a little neater here and get rid of these counting numbers. And this would be my binomial expansion. Looking at our last example, so you see I've included an extra coefficient as well as a fraction in this example. So this is to the 6th power, and this is a negative, so that means that I'm going to use the 6th row in Pascal's triangle, and I'm going to alternate the signs. So I will use 1 minus 6 plus 15 minus 20 plus 15 minus 6 plus 1. Now I'll use my first term of A and my last term is B. In the expansion, I'll have 1 times A to its highest power minus 6 times A gets smaller by 1 and B begins to grow. So it starts with 1. All along, the degrees are always adding up to a sum of 6. Plus 15. If it gets confusing, you can start marking off what you've already completed. So we'll have plus 15 times 3p to the 4th power times 1/4 to the 2nd. Notice my 4 plus 2 gives me 6, minus 20. We'll have 3p being lowered. We'll have 1/4 being raised. That should be to the 3rd power, not to the 4th power. Plus 15, 3p to the 2nd, 1/4 to the 4th, minus 6 times 3p to the 1st times 1/4 to the 5th. And we will finish with plus 1. My 3p will go to the 0 power, which is just 1, times 1/4 to the 6th power. So this one is a long one. I'm going to count my terms. I have 1, 2, 3, 4, 5, 6, 7 terms. That's correct. I should always have the number of degree plus 1. I have 7 terms. And I double check to make sure all of my degrees are equal to 6. So I see 6, 5 plus 1, 4 plus 2, 3 plus 3, 2 plus 4, 1 plus 5, and 6. Now the last piece of this is to collect all those terms and expand your exponents. So for my first term, I'm going to have 3 to the 6th power times 1, which gives me 729p. In the second problem, I'm going to have 3 to the 5th power times 6 times a 4th. Now I'm going to leave that in fraction form, and that's going to reduce to 729 halves, p to the 5th power. I forgot my p to the 6th power back here. Plus, I'm going to take 3 to the 4th power times 15, and then I'll multiply that by 1/4 squared. Remember that 1/4 squared is going to be 1/16. So when I simplify that out, I'll get 1,215 divided by 16p to the 4th power. Minus 3 to the 3rd power is my 27 times negative 20 times 1/4 to the 3rd power. That's going to be 1/64. Now when I reduce that fraction, I'll end up with 135/16 p to the 3rd power. Continuing on, I get 3 to the 2nd, which is 9, times 15 times 1/4 to the 4th power, and that's going to simplify down to 135 over 256 p squared, minus 3 times 1 times negative 6 is negative 18 times 1/4 raised to the 5th power, and after you simplify, we'll get negative 9 over 512 p to the 1st. And the last is simply expanding 1/4 to the 6th power. So really it's 4 to the 6th power is 4,096, but you'll have that in fraction form of 1 over 4,096. So this is our final polynomial after we expand our terms. Let me know if you have any questions.